Hello all, my name is Ashutosh. I am a teacher by profession. My mission is to impart quality education for all. For that purpose, I am creating these videos. If you appreciate my work, then please do like my video and subscribe my channel so that I could get the motivation to prepare more videos. Anyways, today in this particular lecture, we are going to discuss about the handoff process in your mobile communication systems. So these are the outlines. We're going to start up with the introduction where we're going to describe whatever we have studied in our last lecture. Then we're going to define handoff process, what it is. Then we will going to discuss about handoff region, that is at which particular location your handoff will going to take place. Then we're going to discuss how we are in a state to prioritize our handoff since it is the measure of your quality of service. Then finally we're going to conclude by discussing some of the practical handoff problems. So in our last lecture, we have discussed about the cellular capacity, what it is. We have already evaluated that C is equal to MKN, where M is the replication factor, K is the number of channels in a particular cell, and N is the number of cells in your cluster. We have also discussed about the various channel allocation techniques such as your fixed channel allocation as well as dynamic channel allocation. Also, we have described the various advantages of your dynamic channel allocation over your static channel allocation. Now, in this particular lecture, we will try to describe the handoff process. So, in our cellular communication, we had already discussed that user is having the feature to move while conversating or transmitting its signal. So there might be the case that while moving, the user may move or enter into the another cell which is in the coverage of another base station. So in that particular scenario, how it will going to get access with the network. So scenario is quite clear. When a mobile moves into a different cell while a conversation is in progress, obviously a call is going on, then your mobile switching center automatically transfers the call to a new channel belonging to a new base station. I mean, if particular user is moving from one cell site to another cell site, then its serving base station might get changed so that its call may get continue or it may not get dropped down. So two important tasks that must have to be involved in your handoff is, first of all, identifying a new base station. We need to identify a new base station or the particular base station in which your moving subscriber is about to enter. Then channel allocation in the new base station. Then we have to describe or given new frequency bands over which our user's call may get continue. So handoff must be performed successfully, infrequently, and it should be imperceptible to the user. So these are specific key points for your handoff, that it should always be successfully done. Just because if it is unsuccessful, then call might get dropped and quality of service will going to degrade. It should be done infrequently. Just as through this handoff process, all the work has to be done just like your new call connection. So it is better for us that it has to be done infrequently and it should be imperceptible to the user. So here important point is, user who is basically talking shouldn't get any idea that at what particular time its call get disconnected and reconnected. So it should be completely imperceptible to the user. We had already discussed that high priority, then the initiation request, which is the measure of your quality of service. That is, we should not drop a particular ongoing call due to the network issues. So that is why we are saying that this particular handoff call is having high priority rather than your new calls. It is a measure of your quality of service. So if we are in a state to continue our call without getting any sort of drop, then we will going to say that high quality of service would have been delivered by the network. So now this particular figure is basically showing the handoff region, that is at what particular place our handoff request should get started and before which particular point it should have been successfully accomplished. So here in this particular figure, we have shown these two base stations. This is your base station 1 and this is your base station 2, and here is our mobile subscriber, and initially it would have been connected with this particular base station. So this particular line is basically showing that as user is about to move from this particular base station to this particular base station, or it is moving from away from this particular base station, how with respect to distance it received signal quality will going to get deteriorated. So this particular curve is basically showing power curve with respect to this distance x. So this is basically showing that with respect to this particular distance x, how its power profile will going to get changed. So let us say this P2 of x would have been represented by this particular curve, and it is basically showing that with respect to distance from this base station to this base station, or when user is moving from this base station to this base station, it will going to get this particular received signal strength, or with the distance its signal strength will going to get reduced when it is moving away from the base station. Now let us say this particular point is basically showing your minimum threshold value, That is, if received signal strength is fall below this particular value, then call will get disconnected. So now let us say that our user is moving from this particular point to this particular point, and this is, as we have already discussed, it is basically showing your received signal strength of this particular mobile station. So anyhow, for successful handoff situation, this must have to be performed before this particular point only. If it has been done, then handoff will be successful, and if it is not have been performed properly, then its call might get dropped. So here this particular portion is basically showing the region in which your call link must have to be transferred successfully to the another base station. So hence handoff is made when the received signal strength at the base station falls below a pre-specified threshold that we have discussed. It is necessary to ensure that the drop in the signal level is not due to the momentary fading effect. Here it is the most important point. Since rapid fluctuation in the signal is there due to the dynamic channel conditions, so there might be the case that for few moments of time we will getting certain deteriorated signal strength. So as soon as we are getting this deteriorated signal strength, we should not initiate our handoff call instantaneously, just because in our key point we have already discussed that handoff would have been performed infrequently, since it will going to take up the process of your new call initiation, and we basically do not want that it should be happened as frequently as possible. Hence, base station first have to observe the received signal strength for some duration of time, and just have to point out that is, this is your random fluctuation or momentary fluctuation, or we are still getting some deteriorated received signal strength. If that is the case, then we have to initiate the handoff process, and if it is your momentary signal loss, then we must have to avoid this handoff process. This particular figure is basically showing your improper handoff situation. Here your user is in the coverage of your base station 1 and it is moving towards your second base station, which would have been denoted by this particular base station 2. So in this particular figure, we have basically trying to show the received signal strength level of the individual user with respect to the time. So as we have already discussed, let us say that user is situating or locating at this particular point A, and this is the received signal strength level at particular point A, and it is being connected with your base station first. So this particular point is basically showing its received signal strength at this particular position A, and as it is moving from A to B, its received signal strength is gradually falling down. So here this particular line is basically showing your minimum acceptable signal level or minimum acceptable threshold. If particular received signal strength is falls below this particular point, your call will get disconnected. And this particular point is basically showing us a particular signal threshold level where we must have to be start looking for your handoff. Here this PM is basically representing minimum acceptable signal to maintain the call, and PN is basically representing this handoff threshold, that is the point from which we will going to start initiated this handoff request. That is, if user is moving from A to B and at this particular point A, it is having this much received signal strength, and as it is moving from A to B, its received signal strength is falling below, and at this particular point our handoff request must have to be initiated, and it must have to be accomplished before this particular signal level reached by your mobile user. So since the difference between your handoff threshold value PN and minimum acceptable signal level that is given by your PM, so this delta is basically giving us the difference between these two signal levels. So the idea is handoff must have to be accomplished successfully before this much amount of received signal strength degradation. So here we have produced two cases. That is, if this difference, that is PN minus PM, which would have been given as your delta, if its value is too large, then what will going to happen? And if its value is too low, then what will going to happen? So first we're going to consider that when delta is too small. So obviously insufficient time to complete handoff before call is lost. If this delta is quite lower, it means the time frame in which the user will going to fall below this particular minimum acceptable level, that will be quite lower, or user is not in a state to get the successful call transfer from one base station to another base station. So if this delta value is quite low, then we will going to get more dropped calls. Whereas second thing what we can do is we can make this delta much larger. So if we're going to make this particular delta much larger, so that we will going to get enough amount of time to perform this link transfer or perform this handoff process successfully, then what will going to happen is too many hands off. So the point is, if we're going to increase this particular delta, so minimum acceptable level for a signal to maintain a particular call, that must have to be fixed. And if we're going to increase that particular delta, then we must have to increase this particular signal level, that is from where we will going to start initiate our handoff. If this particular level will going to increase, it means we will going to have much larger amount of handoff request. That is, if we're going to increase them, then there are more and more number of users whose received signal quality will falling below this particular level very frequently. So obviously in that particular case, we will going to have too many handoff requests. So if we're going to have too many handoff requests, then in order to serve them, MSC have to work harder for proper handoff situation. So this will basically going to increase the burden over your MSC. So this particular figure is basically showing your improper handoff situation, since up till this particular minimum signal acceptable level, call would have not been transmitted to your second base station, and after this particular point, call of this user will be get disconnected. So now this particular figure is basically showing your proper handoff situation. So scenario is same. User initially would have been connected with this base station 1, and it is your at this particular point A, and it is moving from base station 1 to the coverage of your base station 2. So as it is moving away from A, so its received signal strength will get deteriorated at up till this particular point, and at this particular point it will going to get sudden jump in your received signal strength, and in this particular situation it is basically get disconnected from this base station, and it is start receiving from your second base station. So its received signal strength will going to abruptly get increased at this particular point, and it is keep on increasing as it is moving towards your second base station. So this particular situation or figure is basically showing your proper handoff situation. So now next point is how we will going to prioritize handoff. So handoff must have to be our priority for proper quality of service. This we have seen. So the point is how we will going to prioritize our handoff. So first method is your guard channel method. So what it is saying, so a fraction of total available channels is reserved for the handoff. Please keep in mind here in this particular scenario, we are basically assuming that out of total number of channels available to us for communication, we will basically going to reserve a fraction of available channels for your handoff calls only. That is, we will not going to take up new call request on those reserved frequency bands. So in case of fixed channel assignment, it affects the system capacity as C is equal to MKN, and if you will going to reserve some of the channels for your handoff calls only and you will not going to take new calls, so it will basically going to affect our revenue or your channel capacity. Whereas it will going to purposefully do well when we're going to consider your dynamic channel assignment. Since in your dynamic channel assignment, we are following the strategy all channels must have to be accessible by all. So as long as we are in a state to cater the user request or we are surplus of resources, up till that moment we will going to allocated frequency bands to our individual users, so that here we can optimally use your available resources. So please keep in mind that here we have produce this comparative analysis among your fixed channel allocation and your dynamic channel allocation. But overall, if we talk about, and if we're going to reserve some channels for your handoff calls only, and if we consider a specific case where all users are static and nobody is willing to form any sort of handoff request, then in that particular scenario it will going to reduce out our revenue. So second one is your queuing handoff request method. So in your guard channel allocation method, we have seen that we will be having certain revenue loss as we are reserving few of the channels or frequency bands for your handoff calls only, and if there is no handoff request, then all these reserved channels will get unused, which is not the effective utilization of the available resources. So what we're going to do this queuing handoff request method is, any of the handoff request is not going to be tackled immediately, although we will going to place them in a queue which is on the basis of first come and first serve basis. So as soon as a particular mobile station feels that it is having your received signal strength falls below from a threshold level, it will going to initiate its request, and its request will not going to serve instantaneously, although we will going to place them in a queue. And when channels are available or a particular ongoing calls will terminate it properly, then that resources would have been shared to serve this particular handoff request, and we have to make sure that request must have been performed before your received signal strength falls below the minimum acceptable level. Otherwise, the call will get dropped. So obviously, if we are performing this queuing method, it does not guarantee the 100% success of all the handoff calls request, just because it is not always be the case that we will be having free channels available or a particular potential user have ends its calls during that particular moment. So next one is your practical handoff problems. So here the key point is your speed difference between your various mobile users. So if we talk about your mobile users, different mobile users might possess different speed or mobility. That is, there has to be some static user and there has to be some dynamic user. Dynamic user might be your pedestrian user, or it might travel through your train, car, bus, etc. So I mean, difference in the speeds of users will going to impose certain sorts of practical handoff problems over our network. So what are they? So first of all, we will going to discuss this high speed vehicles versus pedestrians. So I mean, high speed vehicles users are highly mobile user, whereas this pedestrian users are slow moving users. And in our handoff region, we have seen that handoff would have been performed within that duration of time, which is basically the time lag where your individual users received signal strength falls below from threshold value up to that minimum acceptable threshold power level. So if we talk about your high speed mobile users, then that particular time duration is quite lower for your high speed users, whereas if you talk about your pedestrian users, that particular time is quite large or enough to perform that handoff situation. So here the point is, speed will going to impose several challenges, or it will basically going to gives us lesser amount of time for proper handoff situation when user is your mobile with high speed, and it will going to gives us larger amount of time for successful handoff situation if user is having lower speed. So this type of problem would have been addressed with the help of this umbrella cell. So umbrella cell approach is there. So what it is basically saying is, we will going to have certain larger base station which is transmitting your high power. So its particular cellular range is quite larger, and for allowing this particular capacity, we are using this small macro cells for low speed traffic. So as we already discussed that high capacity would have been achieved for installing larger number of base stations. So this particular system will basically going to serve the purpose for your capacity, as well as for this handoff point of view, we will going to provide the services to the pedestrian users or the users which are moving with low mobility. They will going to get services from this particular base stations, and the particular user which is moving with high speed must have to give services from this particular base station. Here idea is quite clear. If we're going to give the services high speed user from this particular base station, then we must have to perform very frequent handoff, just because very soon your large speed mobile user will going to move from this coverage area to another cell. Whereas if we will going to give services high speed mobile user from this larger cell, then we may not have to cater frequent handoff request. So this is how, with the help of this umbrella structure, we will going to solve this particular speed difference problem. Then next one is your cell dragging. So pedestrian users providing a very strong signal due to the direct line of sight. So a pedestrian user, if it is moving out, it might get having certain direct line of sight connectivity with your base station. So if this is the case, then they will basically going to get this strong signal reception. Although there might not always be the case that we will be having some direct line of sight connectivity, but still we can say that pedestrian user or slow mobile user will going to have some better received signal strength, since their movement is very slow, and so is the power deterioration rate. Hence serving MSC do not perform handoff instantaneously. So we had already discussed that handoff must have been performed as infrequently as possible, and for that sake MSC have to monitor for certain duration of time about the received signal strength of the individual user. So if its signal is deteriorating very slowly, then MSC will not going to instantaneously perform its handoff request. It must have to monitor for certain duration of time. That is, that signal is deteriorating continuously or it is your some rapid fluctuation. So during this dilemma, as the signal strength is deteriorating very slowly, MSC might instruct your base station to increase its gain into certain direction of user, so that user will going to get optimum SNR level at the receiving side. So in this situation, when user is moving from one cell side to another side, they will basically going to drag out the boundary of one cell to your another cell, which will going to provide the interference to the other users. So due to this cell dragging, your cell shape will get changed, and it will basically going to provide some interference power to the other users who are lying in another cell. So just in order to limit this particular cell dragging, MSc must have to handle this handoff situation properly. So hopefully you guys have got the insight about your handoff, its practical problem, and how we're going to overcome them. Just in case of any doubt, you can ask me in the comment section. I'll try to solve them out as soon as possible. So these are the references. Thank you very much for your patient hearing.